Someone tell me, how do electric guitars work? All right, let's see. Cart, you're the winner. How do electric guitars work?
Guitar pickups on a tiny coils with magnets inside them.
Mm-hmm.
Magnets magnetize the steel strings.
Yep.
When the strings vibrate, voltage is induced in the coil and then boosted by an amplifier.
Yep. So magnets magnetize the strings. Okay. Strings vibrate. Causes a changing magnetic field. Okay, and then the pickups contain coils that detect this field and produce a voltage, well, EMF. And that EMF is what is then produced and sent to the amplifier, and the amplifier turns that voltage into a sound. Okay? Good. All right. How about generators? How do generators work? Landon, what can you tell me about generators?
They generate electricity by rotating a coil or stationary magnetic field.
Good. So they rotate a coil in a magnetic field. Inducing an EMF. You can do it the other way around too. You can leave the coil and spin the magnet. So you can do it either way. Which a lot of people will say, well, if that's all it is, can you just like hook a magnet up to a bicycle tire and like when you spin the bicycle wire, it spins the magnet and you just put wires in it? Yeah, you can absolutely, like you can make really, really simple generators that you can do just by like a hand crank. In fact, I had one a number of years ago. I had a flashlight that you shake the flashlight, had a magnet in it, and it would go in and out of a wire, and it would induce a magnetic field or induce an EMF, and then you could turn the flashlight on. You can do it with like hand crank flashlights too. I have an emergency radio that's a hand crank radio. There's lots and lots of examples, but they all do the same thing. They either rotate a coil or they rotate the magnetic field. Either way, and it induces the EMF. All right, last one. Generators make AC. Batteries make DC. What's the difference? God bless you. What's the difference between those? Yeah, Braden?
AC switches between positive and negative, and DC is just straight.
Yeah. So if I've got a coil of wire and I'm rotating a magnet in it. So here's my coil of wire. Here's my magnet that's rotating. Here's the North Pole. Here's the South Pole. And it's rotating around this way. What's going to happen is it's North Pole up right now, but as it rotates, it's going to spin, and then it's going to be South Pole up. And then it's going to spin and be North Pole up, and then South Pole up, and North Pole up, South Pole up. It's just going to keep doing that. So AC keeps switching direction. DC does not. DC stays in the same direction all the time. So AC flips the direction, but DC does not. DC keeps the same direction all the time. And that's why batteries produce current in only one direction. whereas electronics, not electronics, things like your car and the power in the walls produce changing fields. That's why you need an adapter for your computer. Computers run off DC power. So if you plug it into the wall, that's AC power, you'll make your computer explode. So you have an adapter that changes it from AC power into DC power. Yeah, Braden.